Welcome to another episode of Discover, Fail, and Learn. Today we're going to be going over conductive 3D filaments. The reason I'm interested in this is because I kind of do, circuit boards on the side, just more of a hobby. And I've always, etched my own boards or sent them in to a site to have them do it. But I was just curious. It's like, I wonder if I could 3D print some boards and do it that way. It's just a lot less messier than using all the chemicals and the etching solution and so forth. So I was kind of curious and did some, Google and Amazon searching and found various filaments that said they were conductive. So I was like, hey, I'll try a whole bunch of them and check them out and see how conductive they are. Some are, not too bad, and other ones are kind of expensive. So I'm just kind of curious to see if the price is worth it and just test them all out. So I'll be going over, let's see, I have 3 different filaments. I have this one here by, Protopasta here. And when I start reviewing them, I'll actually put the Amazon or the other site posting of the price and all that good stuff and their claims and so forth. And then I'll actually look at those claims, the conductivity claims, and see if those are, accurate. And if so, are they actually worth making circuit boards for? So here's the first one here, if you can look at that. It's the Protopasta, interesting, electrical here. So I'll be doing that one. And then I have another one here. This was on Amazon. And like I said, I'll show that when I review that one. And this one is a Yosu one. I have 2 more on the way that I will do in the reviews once I get those. All right, so the other filaments I will be doing are, once I receive them, are the Wrapper. Hopefully I said that correct. Filament. And then the other one is by Multi 3D, which is the most expensive one. Has a lot of claims, so we can see if it's worth it. And then, so at the end, after I review all the filaments, then I'll do an overview, basically, and talk about what filaments are actually worth using for circuit boards, and then, money and the cost versus use and if they're worth it. So let's get started. All right, welcome. So it's been a while since I filmed the first part of this video. Since I've, Christmas came around and New Year, so happy New Year to everybody. But yeah, so in the meantime, I also printed out a whole bunch of filament here. I got the standard filament just from the spool, and then I also printed out some sizes here, and I just did it different widths. So as you can see, the skinny one, a little wider and stuff, just to see if that changes anything after it's printing. So yeah, I did a standard length, the tape measure here. So these will all be about, 4 inches long. That's my standard here. So let's go ahead and do some tests here. So I'm going to go ahead and start with the standard PLA. This is just a Bamboo Labs PLA green. So we're going to try this, and I'm expecting not to have any conductivity here, so we'll see. So let's start with the unprinted. And, yep, nothing. So, all right, let's just try all of them just to be sure here. So yeah, we're just getting a total insulator here, really. Okay. Which is to be expected. I mean, it's basically plastic. Okay. So we'll put these over here. Actually, I just put them back. So now we're going to try these. I'm just going to touch it on these here to make it easier. If anybody's wondering, I'm using the X-Tech multimedia here. I have a few. This is a good one, the EX330. If you ever watch EEV blog, that was one of the the lower price ones he recommended, and it's been really good. So, and it's just easier to read. I have my fancy Fluke one over here that has the graphs and all the weird stuff on it, and it's actually sometimes more complicated to use, and is harder to read and so forth. So these simple ones are really nice. All right, so I'm going to go ahead and read these out. Just lay them out from small to big. See if I get it here. See what the resistance is. So we're going to tap that one here. We get 0. From this one we get 0. This one we get 0. I'm going to try not to touch these here so it doesn't get... Oh yeah, see, it's going to get my resistance here through my body. So this is a worse conductor than my body here. So 0. 0, and it looks like it takes a while to read, so wait a couple of seconds. Okay, so nothing for these. So these standard is not conductive, doesn't work as a resistor, great insulator. All right, let's move to the Protopasta. And actually I'll put a link of the Amazon store right up here. So go ahead and take a look at that if you want to buy it. Again, let's see. So this filament is, as you can see from the price in the Amazon link, not too bad. And printing-wise, this prints really well, just like the standard PLA. So no issues printing it. So that's always a good thing. And yeah, so it prints really easily. So if it doesn't work for using it for resistor here, or conductive material, then you can always just standard print it. And if you look here, it says useful and usable, which is true. Conductive PLA is a resistor for LEDs and interacts with touch capacitive devices. So, okay, let's go ahead and try these first, just to save me some time from screwing those things on, those little attachments. So we're going to go ahead and try this first. This is the printed PLA here. Go ahead pretty much to the end. Oh, there we go. We're getting a reading. So we're going to do a 5-second rule. Okay, 2.45 kilo ohms here. Take these out here. I did a little testing before too. I wanted to redo this video, so that's why you see those values there. All right, let's go to the next one. All right, looks like we have 1.57. Call it good. And this will go from smaller to bigger here. Get these out of the way so I do not mix this up. Yep, I know you want to shut off. Don't shut off yet, please. All right. Yep, pen won't work. 2, 3, 4, 5. 1.26, I think it was. Okay. Get these out of here. All right. Try the next one. 3, 4, 5. 1.59. 2, 3. 1.19. Sorry for bumping the camera with my head there. We're going to get a little higher. So yeah, okay. So generally speaking, not always. There's one little weird here. The wider you make it, a little less resistance it has. All right, so let's go ahead and put these on now. Okay. Let's test these out. These are just the pre-printed filaments. 1, 2, 3, 4, 5. 3.41. We got 3.41. Do that a little more on camera here. Okay. Try the next one. One, 2, 3, 4, 5. 3.48. Okay, try one more, last one. One, 2, 3.37. Okay, pretty consistent. All right, let's move to the next one here. Move this off the side. Okay, now we're going to work on the Yosu. Put the Amazon link here in the description, or at least the description here. And what does this say? All right, so this is saying high conductivity. A resistivity of 7 ohms per centimeter. That's interesting. So we could try that here. We'll do that test right here. Actually, we can do that right now. Yeah, use it like projects like key fobs, LED gloves. Okay. So my notes on this one. Let's try to get the notes here. So, okay, so yeah, this one printed okay. All right, so first of all, well, let's try their tests. I'm going to do it this way first. I'm going to get the printed and unprinted, and then let's just test out what they said. So it said, I can start off right here, and they said 7 centimeters. I'm sorry, for 7 ohms a centimeter. Sorry. So we can test that out right now. So we're going to go right here. We'll just, for the benefit of the doubt, go in the middle. Make sure we got that right. Move it over a little more, maybe. Kind of tricky to do this. Okay, that's about right. Yep, that's good. All right, and what are we getting here? A 0. Okay. Well, that's not very conductive now, is it? So let's just start doing the test. Actually, let's try it with the printed now. Maybe that's the difference. Ah, let's change it. There you go. That's plus 7. 7 ohms per centimeter. I apologize. I keep saying that. So that's 1. Okay. Well, that's interesting. It did start to go up. Make sure those are tight. Yep. So yeah, I don't. I don't see anything for that one. Not looking good. Not looking good. So we'll go ahead and measure these now. Obviously, if it's 0 for that, I'm going to say it's going to be 0 for the whole thing too. 1, 2, 4, 5, 0. Okay. So let's just do pre and post. So we have a big 0. Move this over. Move these out of the way. Yeah, we are in ohms. Okay. Nope, 0. Just double check here. Yep. So see, it does work. Zero conductivity for these. Not looking good. All right, I'm going to go ahead and pull these off. And line these up. I just put 0s for all these. All right, hopefully this is better. 1, 2, 0. 0. 0. And to test this again, if we touch them together, there it goes. So see, it is working. It's just not conductive. Poke in it, maybe? Nope. All right, so yeah, I think this filament's a lot of made up things. So I don't think so. This would be horrible. Like I said, if you just use it for no more printing, it works fine. As you can see, just normal PLA. If you want anything it's even somewhat conductive, it works better as an insulator. All right, let's get on here to the next one. Move this out of the way. The Rep Wrapper. Cool name. This one printed okay as well. Yeah, I printed this one out and it seemed to print fine. So if you have some, you can use it as a normal PLA filament. Same settings, didn't have to change anything. Great stuff for printing at least. So we'll see how conductive it is. All right. What is your guess? 1, 2, 3. Okay, there it goes. Wow, okay. That's a little shaky there. Make sure those are on. Okay, it's very... very picky. Maybe the printing will help with this. Trying to push it in there. Yeah, if I push it in there, kind of comes up and then goes away. So we'll do the 5-second here and just say 0 if that's what it's doing. Let's try this one. So I grip it, it pops up. Okay. Yeah, so see it's going up in the mega ohms and then goes away as not conductive and back. So this is just very, very high is what it's telling me then. 1, 2, 3, 4, 5, then it goes away. So I think it's just a lot of resistance in there. All right, let's try the other one here. Let's try these now. I'm thinking these might be a little better. I'm just going to count those zeros for now. If you think I can try different to test those, let me know and I can retest them. 1, 0. Okay. Trying to push it in there too. 0. Okay. Oh, that one just popped up a bit at high resistance and then went away. I'm going to count at 0. Again, using 5-second count. 0. Yep, pops up high and then goes low. So I'm just going to say these are not very conductive, not worth printing boards with or anything. So I'll give that one a, we'll just say zeros for all. Pre and post, print 0, 0, 0. Okay. Now to the exciting one. Alright, so now we get to the multi 3D. I will post that up here because it's worth seeing how much this is. And it's not cheap. And I also want to point out some other stuff here in the documents. The print temperature, it's very picky, 140 to 160 Celsius. With 1.75 is which I had, so I'm just going to circle that one. And heating bed should be avoided if possible, which I did do. And has some notes to Ultimaker users here. Now I would just, and it also says here to print 10 to 45 millimeters a second. So on the bamboo, I did all this stuff. I set all this up to be very picky like that. So obviously it's not something you can just stick in like a PLA and print. It's not that easy. And once I set that up, I still cannot print on my bamboo because there's on the top the AMS that automatically spools it and so forth. And there's a couple of kind of turns, and this stuff is very fragile. I'll show you in a bit. So if you're going to print it, it has to be as straight from the spool to the head as possible or it will not print. But I'll show you in a bit. After I measure these, I'll go ahead and just show you how they break. But let's get started with the unprinted here. Let me reset this multimeter. Okay. So yeah, not impressed with printing with this. It's just not easy. I'll tell you how I kind of got around that. Let's go ahead and measure this here. I'm hoping this will be conductive, just with how much of a pain it is to work with. At least they'll have something going for it, and the cost is not cheap again. Okay, let's see what we have here. Okay, it's coming up. Oh, gee, that's jumping all over the place. It does say it's better when you print it, so I'll give it that. It's bouncing all the way to kilo ohms to mega to... Yeah, so we'll just try another one. It's unreadable. But it's going to be hard to test the printed as well. You'll see why. Oh, do we get a reading? Oh, 9 mega ohms. It's just jumping all over. And of course with a circuit, I think you would want it somewhat dependable and consistent. Sorry, my cat hairs are getting all over this. Yeah, that's just not... Okay, you can't even read that. All right, I'll show you how breakable this is now. So if you see it just broke just like that. Put that up to the camera here, just snap. And now this has been out a little bit, but I took it right out of the package and did it, and it was just about as easy to break. But if you have that in any machine that goes around and twists it a much, it just ends up breaking, or as you can see now, it's compromised there. It's just really hard to work with. So even if it isn't conductive, you can't print with it on any normal printer. Yeah, it's a mess there. So I'll show you how I did it. So what I had to do is use my son's, he has a 3D pen that he got for Christmas. And you can put it straight right in. You can adjust the temperature to what you want, and you can make the feed rate really slow. And you're putting it on plastic, so there's no heated bed, so you're following all these rules. And I tried to print out like a straight thing to measure. And as you could see, well, first of all, my skills with 3D pen aren't that great, but it was still kind of hard. So you could see this was like a strip. Hopefully you can see that. It was a strip like this long when I put multiple layers on, and it just fell apart. It's just so fragile. And it's just not fun to work with. So we're not going to be able to get the 4 inches here, but we'll try maybe this one to see if this is conductive. And this is going to be, okay. 1, 2, okay, I'll just call it 1 kilo ohm. So we're going to do a pre and then a post. We're just going to use question marks because it was hard to read. So let's just say 1K. So it is more conductive. Again, this is shorter though. So if we take the best filament we had and measure about the same length, what do we get on that one? Okay. Oh, 0.793 kilo ohm. Okay. And this one obviously is not touching in solid very well, but if we do that one, 0.6, now it's up to 1. Oh, boy. Yeah, it's just so sporadic, whereas this one, oh, gotta stop touching that. See, it stays around that 7.7374, whatever, so it's more consistent. It is more of an even flow though, but as you can see, this stuff is just, and especially for this price, it's just a waste of money. Somebody can prove me wrong on that and a better way to do it, let me know, but I'm sure it's not going to be some simple process of how everyone can use it. Yeah, it was not fun to work with. I am not impressed with it, especially with that price. So I feel pretty ripped off. So yeah, I would not recommend using Multi-3D for standard printing, for conductive printing, not at all. And it looks like the winner then, out of all these filaments, would be the Proto. So it prints well, and it's somewhat conductive. Again, it would be more of a resistor than it would be you know, like trace lines or anything. They have nothing that can do that now. So if we test this right here, we're just going to go out and we're going to do, since this is obviously the true winner here, we're just going to go out, let's do it by inches and just see the difference. So if we start off here, I go to 1 inch, we're going to get about 0.73 kilo ohms. We go to 2. 0.79, okay. 0.93, and out here, 1 kilo ohm. And I apologize, this is partial of a, this is just ohms then. So yeah, at 1 we have 740 ohms, and then we have 832 ohms, and then we have 920 ohms, and then over here we have 1.05 kilo ohms. So yeah, there's some resistance there. It's not a huge amount, but enough, like I said, you can make resistors with it, I'm sure. I'll do a later one if you want to see that, where I actually test, you know, putting current through it. And I've seen videos where they do that, but maybe I could put current through this and put more and more current through it to see how it acts, if it softens up, what happens. All right, but overall, yeah, the Proto looks pretty good, at least for the price and everything. Again, you couldn't really make much traces with it, but you could, you know, I don't know, it'd be kind of cool if you could just print your own resistors for circuits and just call it that. But that would be another project. So there you go. So those are my thoughts on those. So yeah, don't waste your money on the Multi 3D. Please don't waste your money on that. But you have the other ones that kind of, the only one that was really that conductive. If we go over here again, the Rep Wrapper just wasn't conductive. The Yosu wasn't. And then the the Standard, of course, was not. And then the Protopasta was decent. And look, you can even use it before a little as a resistor, even before you print it. It's just a little higher if you want more resistance. You can just print it right off the spool or cut it off the spool. But printing it will just bring it down a little bit. So, all right. Hope you enjoyed that. This was a lot of research and printing and trying this and that and stuff. So we put a lot of work into this one. So, yeah, please like the video and comment. All right. Thanks. Have a good one.